So Eunice, you can share your screen. Show us your solution for that question.
Okay, yeah, nimeona nimekosea. I have mutated my.
Mutate array.
Yes.
Haina shida. I think basi we'll look at it afterwards. I'm supposed to join tuoneshe solution yake, but since she sent it to the group, I think we just wait here for Joseph, because Joseph I'm pretty sure pia alikuwa ameifanya, but we'll continue na other stuff before they join in. Okay. See. I'm just looking at some code hapa. Okay, let me share my screen. Okay. You can see my screen. It's visible.
Yes, it is, Ian.
So maybe we can walk through it pamoja. We see how to solve it. So the question was we needed to sort the array without mutating the original array, basically. So ascending. So first of all, sort in ascending and descending order on the upvotes. Just push this down. So let's first of all deal with this one, sorting the upvotes, which is these properties in ascending order. How would we go about that using the sort? So from smallest to largest. So I think we should start from the array we should start with 1, this one that has upwards of 1, and then 2, and then 7, and then 12, and so forth and so forth. Baka, I think the last one should be 72. But we are not supposed to mutate this original array, this one that's called articles. So how do we go about that? How do we do that? Anyone wants to give it a shot? Or can we use sort to sort that in ascending order? How do we start? Anyone? What's the first thing we need to do?
The first thing we need to do is to make a copy of that array, articles array. Pardon?
How do we go about that? What do we do?
So we define another variable. Then we use the okay. What are you going to call the variable? Let's say array copy is equals to. Then use the spread operator to make a copy for arrays. Yeah, articles. Then we use the sort function to sort.
So A and B, and then what do we write here? Now you need to sort in ascending order.
So we write A dot. We are sorting using the upwards, right?
Yeah, we're sorting upwards first.
A dot upwards minus B dot upwards.
Okay.
Minus.
Minus. And then so I'm assuming what about descending? Same thing but in reverse.
Yeah.
Okay, so I can call this descending. It is actually ascending. So I can just take this and just change to descending. So we change, what do we change here within the body of the function, the arrow function?
We change becomes yeah, a B dot upwards minus A dot upwards, I think.
You confident with your answer?
The sorting part, I'm not confident.
So we've made a copy of our original array. That's what we're doing here. We're simply taking all the contents from articles and putting them in a new array. And then we are sorting that new array. So if we console log ascending, see, I will use Node to run this if I have anything else to change. So I will remove sort. We are console logging ascending. We'll use Node to run this up. So let's see whether we got it or not. So the last thing should be 72, which it is. The first one should be 1, which it is. So we have sorted in ascending order. So if we just swap this out with descending, then it should also work. Yes, so it also works. Because now the last object has upwards of 1. Then the first one is 72. So it's working. Yeah, so you are right, Daniel. That's how you do it. So I'm assuming, what if you want to sort the dates? What do you think? What do we call about that? Now we want the dates. We want to sort ascending and descending the date property. Do we use the same framework tufanye tu vile tumefanya hapa, but now we swap out a dot upwards with the date? We do that.
I have a question.
Yes.
Like when you're this ascending upwards, when you don't make like the copy of the articles and you sort the array just like that, does that mean that you'll be mutating the array?
Yeah. If you don't make a copy and you sort it on the articles, you are actually changing your original articles. So let's see. So now we have descending here. So descending is arranging, is sorting based on the upvotes. If you log, if I just comment this out because I don't want to populate console, then I log articles, I should see the original one kama ijaguzwa, it still be the same. So you can see it's the original array. It's this one that started off with 12 and then 22 and then 2 and then 72. So you can see it did not touch the original array. Is that what you're asking?
Yes.
Okay. Yeah, so if you make a copy, you will not mutate the original array, which is what we did. So for the date, I want to give it a shot now based off of what we've done with this. We'll assume we need to first of all have ascending and it, and then what do we assign it to? We will use the same equals dot sort, and I'll pass in a callback function. And I will do an implicit return. Okay, so now here number 2 number A and B. But what do we put here? I want to sort according to the date. Do we do A dot date minus B dot date?
I think since the array is like taken in a form of string, you're going to create a date object with new date.
So we do it here. Or where do we put the new date syntax?
You're going to put it new date, then brackets a dot date.
Then I do the same for this.
Yes.
So remember when we did constructors, there is that new keyword again. See whether we got it. So ascending, so we are going from the oldest, right? So 2010 and then 2019, January, and then 2019, October, then November 2019. So it's working. So we have sorted in ascending order. So it's okay. So if you want to do the opposite, then you simply change the functionality here. You now do new date b dot date minus new date a dot date. It will still work. So what if we did not give it? What if we did not pass in the date? What would have happened? How would it have sorted the array? See if it works. What happened? Let's see. What's the original array? 2010. So nothing happened. 2010, 2019. Yeah. So you need to pass in the new dates for you to be able to sort. Okay, I implemented it a bit differently, but I'll push the code to GitHub because I used a function. Let me first of all comment this out. I don't want to go through the whole code, but it's very similar to what Fatma had done. So first of all, I did it the way we just done it, and then I then now used a function. So my function takes in the array, and I also take in the order, so whether it's descending or ascending. Then I take in the sorting property. Then I make a copy of my array, something we were doing initially, which is here. And then I check if order is equal to A, which is ascending, and the sorting property is equal to date, then I want to return this. So I want to return an array that is sorted. Then new date, then A dot date minus new date B dot date, what we just did at the top. Then if order is descending and the sorting property is date, I just do the opposite. And then now I do the same thing for upvotes. If the order is A and the sorting property is upvotes, I sort them in ascending order. Then if the order is descending and the sorting property is upwards, then I do the opposite. So now if I pass in those values here, I pass in the articles, the array, I pass in the order, whether it's ascending or descending, then I pass in the property, which is upwards. If I console log this ascending upwards, you get the same thing. So now this should be sorted in from the smallest to the largest. So upwards, 1, 2, so it's working 7. And then I can also do it with descending upwards. I pass in the articles, I pass in the order, and then I pass in the property, which is upwards. And I can still reuse the same function to also sort ascending date and descending date by simply changing the property. And it will still work. So I will push that code and then you guys will have a look at it. Who else was able to do it? Has Joseph joined us? Fatma showed us her solution for the group. I guess hajakuja bado, maybe he'll join baadaye. Okay. All right, so before we...
I've got a question.
Yeah.
I've seen in your function that you are copying the array to a variable and then you are returning, yeah, there. Okay, I'm not sure, but I think since because you're spreading in the return, you can actually work with the original array rather than create another copy.
So we remove this.
It will not mutate.
We just work with the array copy.
Yeah.
Very good catch. I had seen that, but I was not sure. I think my initial implementation, what I was trying to do, I was trying to make a copy without like declaring a new variable. No, it was not better. See. Yeah, it still works. That's a good catch here. So we don't even need to destructure again. We don't need to spread again. Don't need to have another array. Yeah. Right, so I think this one, whatever is left, you guys can just have a look for GitHub. You look at my solution, you can look at Fatma's solution. Joseph to join. If he has something to show, then he will trust what he did as well. Okay, so now I think we can start with the discussion for whether JS is interpreted or compiled before we go into anything else. Is Fred here? Fred, am I join? Has Fred joined the session? I guess not. Okay, so for what do you guys understand by those two terms? Compiled languages and interpreted languages. What do you guys understand by those two terminologies? Anyone with wants to share? Nelson, what do you think? Anybody who wants to give it a shot?
Not sure of how correct I am, but a compiled language requires the source code to be transformed into machine code so that it can be executed, because it can be interpreted line by line, like JavaScript can in the browser. So it can work both in a browser environment or Node.js environment without needing like an explicit compile step. So it's an interpreted language, not a compiled language.
Okay. All right, so Fatma says interpreted. She's also explained compiling. Who wants to chip in on that? Who wants to give it a shot? What do you guys understand by those two terms? Compiled, or let's start here. Have you guys heard that computers understand only zeros and ones? Has anyone heard of that before? Binary.
Yeah.
So how come when we write our code, we don't write in zeros and ones? Because we are talking to computers.
So that's where the issue of compiling and interpretation comes in. Basically, all my computers just understand machine code, which is just binary.
Yeah. So that's where compiling comes in.
So that the processor can execute it.
Okay, very good.
While
So that
an interpreted language is where implementations, the implementations execute instructions without directly compiling into machine code.
Okay. So it doesn't when you're doing interpretation, when you're working with an interpreted language, it does not compile it down to machine code.
Yeah.
So what does it use?
I'm not so sure about that.
No problem, because this thing is very confusing for a lot of people, especially if you started with a high-level language like JavaScript or Python. It's super confusing, because when you're working with JavaScript or Python or any high-level language, you don't need to go through that build step of compiling. So the way to think about it is, computers do only understand zeros and ones. At the end of the day, that is what your CPU is going to understand. It has something called an instruction set that knows what those zeros and ones mean. Lakini, they are different. Those instruction sets for an Intel processor are different for a Mac processor. That's why kuna shida cross-platform applications. So when you're working, if you're working on, for example, Mac OS, the installation file is not the same as installation file yake ya Linux ama ya Windows. They're different. The executable is different, even though it's the same source code. Sindio? So the way to think about it is compiled languages. If you have a compiled language, just the way Fatma has said, before that application is run, before it is executed, it has to be compiled in its entirety. So if you've ever worked with C or C++ or Go, anytime before you run your application, there's usually, you have to talk to the compiler. The compiler will go through your code yote, then generate an executable file. So when you download a file on Windows, application on Windows, unapatanga that .exe, that executable file. That is your compiled code. So things like C or C++, they come with their own compilers. I think Yasi inaitwa Clang. So before you run the app, you have to compile it. Now, JavaScript, if you're really keen, when you got your machine, you did not have to install JavaScript, right? Iko tu kwa browser yako. It's not something you had to install. That's because JavaScript, right, the way it was created the first time, it was interpreted. Because what happens is there's something called a JavaScript environment. So that is basically an environment where JavaScript can be run. One of those environments is the browser. We talked about the call stack. We talked about queues, the callback queue, the one that is used for asynchronous behavior. Now, all those things together, the JavaScript engine, the call stack, those APIs like fetch API, the call stack, the memory heap, they make up the JavaScript environment. That's why, and we did an example. If you come to Node right here and you press enter, it will open up an environment, a JavaScript environment for you. Hapa, you can write JavaScript code because it has access to all those things that you need to run JavaScript. Compare that with a compiled language. You need to have an executable file that you can run on your machine. It doesn't come, you can't run it on the fly. So with compiled languages, it has to wait until all your code has been read and then compiled into machine code or bytecode, and then now execute it. Compared to interpreted languages, whereby it reads your code line by line and then executes it immediately. Haikojangi. So it reads it, executes, reads it, executes, reads it, executes. Haikojangi doesn't have to wait until the whole thing doesn't package the whole thing. Now, the main difference between those two things, there's a big debate in terms of interpreted languages being slower than compiled languages. Does anyone know why there's that topic of interpreted languages are slower than compiled languages? Because thinking about it, like at a high level, if the interpreted language is doing it line by line, then it should be faster, sindio? Because there's no process of waiting for the application to build and then you run it. And yet, compiled languages are faster. Can anyone take a guess why that is the case? As an idea.
Is it because that they have a direct access to the memory?
Mm-hmm. Good attempt, but that is not why. There's another reason.
Yeah.
Mm-hmm.
You say because the interpreted languages go line by line, they're supposed to be faster.
Because you see, there's no that we are not waiting. When you're dealing with a compiled language, you have to wait for it to build that application first. It has to build the executable file first. Sindio?
Yeah.
In interpreted languages, you don't wait. The minute your engine, for example, the JS engine, the minute it comes across a line of JavaScript, it works on it immediately. It does not wait for it to be compiled. It starts immediately. But compiled languages are faster. So there's two things. When you start compiled language, when you run it for the first time, it's going to be slower than an interpreted language. But that is because of that extra build step. With compiled languages, there's 2 steps, compile and then execute. With interpreted languages, there's just 1 step, just execute. Inasomanga and then it executes. It reads the line and executes immediately. It doesn't wait for a build step. But now, when you now run the applications, the compiled one is faster. It's faster when you're running it. And that is because compiled languages are optimized. So think about it this way. If you have repeated code, come on, for example, if I have, let me remove this. If I have a for loop, right? And then this for loop is saying I equals to 0, and then I is less than 10, then I plus plus, then I have a console.log. Okay. Then I have this a bunch of times, mara mingi kabisa, 10, 20, 15 times. If this was to be done with a compiled language, what it's going to do, it's going to recognize that your code in Afana, it looks very similar. It's like you're doing the same thing over and over again. So what it will do, it will optimize that code so that anytime it comes across it, it does not have to redo the whole thing again. Because it reads the whole file. So as it is reading, it can optimize. It can make it faster. So it can index some of those code blocks and say, anytime I see this particular lines of code, I saw this before, so I can reuse that index that I had, that stored value that looks similar to this. So it's faster because it's optimizing your code. But for an interpreted language, it doesn't know because it reads line by line. So as it's executing this file, it will read this, execute it, finish, and then if it comes across another one that looks exactly the same, it will again read it again. It will not try to optimize it because it doesn't know it's supposed to do that. It doesn't have like a copy or an index to this particular code. It will just do it again and again and again and again. So you can imagine if your application is very big and every time you have code blocks that are repeating themselves, and then you have to run that code again, it's going to come at a performance cost. So that's why inasemekananga, for a very long time, interpreted languages are slower than compiled, much, much slower. They used to be much, much slower than compiled languages because of that extra step of we have to read every line of code because it's reading, executing. There's no time to optimize the code. I don't know whether that is making sense. Anyone with a question, Mambo?
Yeah, I've got it.
You've understood?
Yeah, I've understood because I was actually going to disagree with you, saying going line by line is actually faster.
Yeah.
I had some idea of that in the case of a for loop.
Yeah, it's faster at startup. Like when you start the two of them, it's faster because see, it doesn't have that step of waiting. Aigojeangi. But now, when you are running the application, kuna tofauti, there's a difference. They used to be very slow, but nowadays they are not as slow. So your JavaScript has to be consumed by something. Because we have said that programming languages, like computers, only understand zeros and ones. So for you to be able to take this code that we are writing right here, that looks very human readable, that is human readable, and make it into something that your computer can understand, that is where interpreters and compilers come in. Because they take your code and then transform it into something your machine can understand. Because at the end of the day, your computer does not know what JavaScript is. Your CPU doesn't know what this is. So it has to be transformed into zeros and ones that can now be consumed by your CPU. That's why we need compilers. That's why we need interpreters. And in JavaScript, if you have a JavaScript environment like Node or the browser, you need a JS engine. The JS engine will take your JavaScript, transform it into machine code, something that your machine can understand. That's why they are there. That's why you need them. And we have a few. The one that is on Chrome is called the V8 engine. I'm sure you have heard of it. It's the same thing that is running Node.js. So compilers are just applications. They're just the apps to, it's not an actual engine. It's just an app. So V8 is written in C++. So it's just an application that takes your JS and then can transform it into low-level language, like machine code. So Chrome comes with V8. Mozilla comes with SpiderMonkey. IE, Internet Explorer, which is now Edge, comes with Chakra. And then I think Safari has another one. I can't remember the name. JavaScript core. I can't remember the name, but even them, they have their own implementation. So for you to be able to run JavaScript on another platform, you need to have an engine. You need to have an environment where it understands JavaScript code. So now they introduced something called JIT. JIT is just-in-time compilation, what was Mambo was saying. So JIT is trying to, it's like a go between compiling and interpreting. So what happens is when your code is being run, right? Now when you have a JIT compiler, what happens is when your application first starts to run, it will still interpret kama kawaida, the way it does it as an interpreted language. So line by line, but there is a profiler, like a watcher. There's something in between that is watching your code as you run it. And then anytime that thing, that profiler, sees code that you are repeating multiple times, it puts it in a compiler, another one, a optimizing compiler that is responsible for optimizing your code. So it's still interpreting, yes, but before ifike kwa hiyo step ya output the code, it's optimizing the code. So we do have the interpreter, but we also have a compiler. So the V8 engine has two compilers. There's a baseline compiler, and then we have the optimizing compiler. So think about it like a road. So the first time your code is run, it goes through the main road. But upper kwa side, there's some code that there's something that is monitoring anything that is happening on that main road. And then anytime it sees, it realizes that some code is repeating itself, it will take it to that optimizing compiler. It will then optimize the code, the indexing. Indexing simply means it will look at the signature of that code and then store like a reference to it mahali. So anytime it sees that code again, it doesn't have to recompile the whole thing. It just gives you the value that it had before. So the JIT compiler actually makes JavaScript very, very fast. That is why you can run web applications. Otherwise, they would be very, very slow. But because you have JIT, the thing that sits between, like when you're interpreting JavaScript, and then it's taking some of it, watching if there's any changes. And then if it sees something that is repeating itself too many times, it will try to optimize it and then pass it now back to whoever is consuming it. So it's like a combination of both of them. It's like a combination of compiling and also interpreting. Because bado hakunanga, there's no build step. You don't have to build your application and then wait for it to be executed. It's still just one thing that is going on. You're still just executing immediately. Because that's why you still don't have a .exe file with JavaScript paka leo. You can't send someone your app.js as an executable. There are ways to do it, but you cannot do that. Any question? That topic is very confusing. So with that, is JavaScript interpreted or is it compiled? what do you guys think with that knowledge now, with that information? Is it compiled or is it interpreted?
I'm going with interpreted.
Okay, you're still going with interpreted?
Yeah.
Mm-hmm.
Fatma also joins me in that.
Interpreted also.
Yeah.
Okay. Who else wants to?
I think, does it mean that it can't be compiled at all, like in its nature, or that? Because I've seen a tool called Google Closure compiler. That does not compile it into machine code. It like makes it better by like removing dead code, analyzing it, like checking the syntax and the variable references and such. I've seen a tool like that before.
You can still compile JavaScript, because remember the thing that is, so C++ can do that for you. We actually have a let me show you. We have something called, if you go to npm, there's a package called pkg that you can use to package your application, your JavaScript. So you can literally take your Node.js project and turn it into an executable file. So you can do it, because at the end of the day, C++ is there. So it knows how to do that. So you can see this command line interface enables you to package your Node.js project into an executable. So you can install it, you can actually build a web app, right? And then you turn it into a desktop application. That is what Electron does. Electron, you're the one that is used by Slack, that Microsoft product. It's using Node.js. But again, Node.js is using V8, and V8 is using C++. So that's how Electron is able to package your applications, because at the end of the day, there's still another language beneath your JavaScript that knows how to compile down to like an executable file. But the browser does not do that by default. It doesn't do that. It's not supposed to do that. So the JS environment is this thing that you see here. This is not something that has been in web browsers forever. I think they were introduced maybe 2008, 2009, I think. You never used to have a console. So this is just something that was added afterwards. This is also a JavaScript environment. That's why you can write JS here and do stuff here, because it knows what JavaScript is. So the engineering behind that whole process of JavaScript engine, it is just like, it is incredible. It is just some level of engineering that requires a lot of thinking. The whole process of taking your code, optimizing, and then running immediately, it's not simple and it's not easy. So you guys can take some time to go through those documentations, the V8, they're all public. But the question, Bado, still stands. So interpreted, Fatma and Mambo. Evans, are you also still interpreted? Still saying interpreted, Bado?
Yeah, interpreted.
Okay, interpreted. Anyone else? Okay, so even for me, I would say it's a bit of both, because we do have compiling. It's like a hybrid kind of thing, because Python does it also. So PHP is an interpreted language. Python is also interpreted, but again, it's also not. There's this group of languages where they do have interpreted behavior, but they have this extra thing, like cheat compiler, that make them behave like compiled languages. So they're like, they are interpreted, but then again, they're really not. They are compiled, but then again, they're not fully compiled. You don't have a build step. That's the thing. With compiled languages, you always have a build step. You always, first of all, you build your whole application, so your .exe, and then you execute it. But with interpreted languages, you don't build and then execute. You just execute. So you can see why this topic is so confusing for a lot of people, and why nobody really knows whether to group JavaScript as, especially the modern JavaScript, as compiled or interpreted. Because of that extra JIT, the JIT compiler, complicates things. It makes it very easy to work with the language, but it also makes it very difficult to tie it down to being interpreted only, and yet it's doing some compilation bado, some optimization. It has a compiler bado. So I think it depends on who you ask. Some people will tell you it's compiled, some people will tell you it's interpreted. I choose to say it's somewhere in between. It's like a hybrid language. Anyone with a question in regards to like the JS engine or what makes up a JavaScript environment? I used to think that the event loop and JavaScript, the JavaScript engine, were one and the same thing, but they are not. The event loop is separate. We have the JavaScript engine, and then we have the event loop, and then we have the callback queue, the one that is used by promises and callbacks. The JS engine is actually made up of the memory heap and the call stack. That is what the JS engine is made of. And then everything else, your fetch APIs, your set timeouts, those things are called APIs. They are extra functionality that now are used to boost functionality for the application for JavaScript. That's why the DOM is not available in Node. If you do document.getElement in Node, it's going to complain because that thing does not exist. Say document, and you try to run it with Node. Document is not defined because document is not a part of JavaScript. The DOM is not a part of JavaScript. It's an API. It's extra functionality that comes with the browser environment, not Node. Node is another environment. It comes with the browser environment because you need to manipulate the DOM. You need to work with HTML. But in the backend, right, you're just dealing with files. So things like the FS module is used to read files. I come here and I say const fs is equal to require s. This is called the file system module. It's used to create files on your machine. So for example, static site generators, you make use of the fs. That's how they're able to do it, because they need to create directories in your file, in your folder structure. So the way they do it is they use Node, because Node knows about the fs, the file system module. We have another one called OS. The OS module. Now this gives you information about your operating system. But these two are not available in the browser. If you go to the browser and you look for OS, you will not find it. Because again, this is just an API, like extra functionality that JavaScript will need on the back end, not on the front end, not on the browser. So all those things, most of them that we interact with, they're not really JavaScript. They're just APIs, extra functionality. Any question? Anyone with a question? Anything I need to clarify?
Yeah. What do you call this node? Node also has V8, right?
Yes.
Okay.
Yeah. So you can even have Node.js, not Node.js, JavaScript running on IoT devices, like embedded, like microcontrollers. Because again, so Nona, if you have the engine, if you have that JavaScript engine, if you have something that can eat JavaScript, consume JavaScript, then it doesn't matter where you put it. If you can put it on like a microcontroller, like for example, let's say your fridge has something that you can program, right, in a particular language. You can just plug in that JS engine there because it's just an application. It's a C++ application. And then you can now run JavaScript there. So the main difference is between browser JavaScript and Node JavaScript is you cannot run Node if you have not downloaded it. Unaona, Node is an executable file. You have to download it and then install it. But browser JavaScript is not installed. You don't download JavaScript on the front end. When you download a browser, you also don't download JavaScript. So when you're downloading Node, what you're actually downloading is the environment, the runtime, like that whole thing. That's what you're downloading. You're downloading a space where you can write JavaScript. And it's always running in the background. That's why I can use FS, because that process is running in my machine. So I can say console.log FS. And it will work because I have Node installed. If I say node-v, I can see I have Node version 18. If I run this file, you can see I'm getting that FS module with all these methods. Any other question? It's a good question. It normally takes some time, but I hope I've given some clarity as to JS engines, even though we didn't go so deep into them. They are like a very complex topic. Mambo, uko sawa? Are you okay?
Yeah, today.
Okay. All right. So let's go to the next thing. If nobody has a question. So I'll push all this to GitHub again. So there's some information about the queue, the microtask queue. What is the difference between when you use callbacks and when you use promises? Because there is a difference in terms of priority. Who is given more priority? Then I have one for the JS engine. I'll push this as well. Safaris is called JavaScript core. Then we have interpreters, compilers. So I'll push this code and then you guys can go through it. So let's do Node School. Okay, so I will. So if you go to Node School Nairobi, you get to Node School, and you go into the workshops and you look for functional. Okay, it is functional JavaScript. So I will put this side by side. Now, this package, this functional JavaScript package, it has a bunch of challenges that you can do to try to improve your functional JavaScript. So you can either install it globally. When you install it globally, it gives you access to this command. So I will do that. I will install this. If you're on Linux, you need to do sudo and then install. So right now I'm doing npm install -g because I want to install it globally so that I have access to this this command anywhere in my application, anywhere in my computer. So now if I try to do it now, it's going to complain because I don't have admin rights for VS Code. So I need to open VS Code as an admin. So I will delete this file and then we can start again. What's going on? So just go to Node School. Did it finish? Then get the package. This one, functional JavaScript. Has anyone been able to install it? If you're on Linux, use sudo. I'm not sure about Mac. Not sure what command you guys use for doing admin stuff in the terminal. You can see it complained. It's saying permissions of the file contain directories I need to run as a root. So that is exactly what I will do. Then I will run the command again. So this, I take this. Might come with some complaint that some of those packages are old. But it's a long near Kitambo, it's what? Okay, it worked. So now once you have installed that package, go into the page for functional JavaScript. So once you run npm install and you install it globally, you can just now run this command in the terminal. So if I just clear this and then I run that command, I should get a list of the $sign is the issue. You can see I get, okay, I don't know what's going on with my terminal today. I run that command, I can see a list of challenges. So let's tackle the first one, then we'll move down. So the first one is, when you open it, it gives you some instructions. So write a function that takes an input string and returns it uppercased. So arguments, we are going to get a string of random words and then the boilerplate. So I will create a new file here, call it 01.js. Then I will take the boilerplate code. I'll paste it in here. And then we'll go through the question. So we need to write a function that takes an input string and returns it uppercased. Who wants to solve that one for us? Don't look at this, just the solution should be here. How would you do that? Simply want to take in input and return it uppercased.
That would be return input dot to uppercase.
Okay, and then now once you're sure of your solution, you can now verify your solution. So you can run functional JavaScript verify program.js. In this case, it's 01.js. So we will run functional JavaScript and then verify 01.js. You can see we passed that challenge. So now we can go to the next one. So that's how the challenges are structured. So if you want to again see the menu, you need to run again functional JavaScript workshop and then go to the next one, higher order functions. So again, we will create a new 02 here, 02.js. And then we will take the boilerplate. Then we'll paste it in. Okay, now let's go through this one. This one looks a bit more challenging. Okay, implement a function that takes a function as its argument. That's the first thing. And a number, num, as its second argument. Then executes the passed in function num times. Let's read that again. Implement a function that takes a function as its first argument, a number, num, as its second argument, then executes the passed in function num times. So we already have the boilerplate here. So we know operation, this operation is going to be a function because they're telling us the first argument is a function. So using this, we know that operation is a function and then a number, num, as its second argument, which is this. Then executes the passed in function, this operation, num times. This is num times here. Okay, let's go on. So it takes in an operation. So it's a function, takes no arguments, returns no useful value. And then num, the number of times to call operation. Okay. The hints, don't overthink it. The code should be rather simple. It's okay to use a for loop in your implementation. Bonus points if you use recursion instead. Okay, you may notice some output. This is coming from the function we passed you. Okay, so we've taken the boilerplate. We now want to solve this thing. So what the question is asking is, when this function is repeat is called, when we call repeat, when it's called, it's going to take a function here. It's going to take a function. And then it's also going to take a number value, like 4. What they want us to do is they want us to call this function 4 times. If we pass in 2, we want to call this function twice. If we pass in 5, we want to call this function 5 times. How do we go about doing that? They've said we can use a for loop. Anybody with an idea of how we can solve that? How can we start? Think about the session we did yesterday about callbacks and functions being passed in as arguments to other functions, because this is directly related to that session. Anyone with an idea? So again, let me repeat. We want to call operation num times. Operation is a function. We want to call it num times. Num is the number of times we have repeat. The first argument is a function. And then the second one is a number. So let's try to do this on our own, like just have like a normal function. Even with this, we can try. So how would the implementation be in here? If I have a function, I'm just declaring it directly here. let me make it easier. Let me say const call me maybe. Then okay, so now here this operation can be now be our call me maybe function. So what the question is asking is we need to call maybe this function call me maybe 6 times. How do we implement that here in the function in this repeat function? Maybe can we use a for loop? Anybody who has seen how we can use a for loop? Anyone want to take a shot? Even if it's just the first step, or what do you think we should do first? Because the first, we can only start with the first step. What's the first thing we can do?
Okay, we can go and we can start with writing a for loop. Like for let's I equals 0. Then if I is less than or equal to num, then I plus plus. Then we call operation inside the for loop.
So we call it. We have the parenthesis.
Yeah.
Okay. Anyone else who has seen, or what do you think of that implementation? Is it making sense? Will that work?
I think this will do it 5 times. I'm not very sure, but I think that it will do it 5 times because it will run for 0, for 1, 2, 3, 4 itself.
True, it will do it 5 times.
Yes. So
yeah, it's supposed to be less than.
Maybe you can use less than or initialize I at 1.
Yeah.
Anybody else who, can we try to see whether it works? Okay, so we will call repeat and we've passed in 6. Okay, so let's try. Let's open a new terminal and let's run. Don't even need this. Let's now run this file. So node 02.js 1, 2, 3, 4, 5, 6. What if we wanted to log the current count value? But we are, first of all, it's correct. That's what we're supposed to do. Because what it's doing, it's for every loop, for every time our num is less than 6, it's calling operation, because operation is a function. Right here, call me maybe. So you're saying you're calling me, you're calling me. How would we also include the value? So we want to say you're calling me 1, or you're calling me 0 when it's 0, and then you're calling me 1 when it's 1. How would we do that? How would we pass the i's? Anyone with an idea of how we can do that? How do we wanted to say you're calling me 0 when it's at 0 and I is at 0. You're calling me 1 When we are at number 1, you're calling me 2. Anyone? Joseph, can you not Joseph? Who can try? Joseph is not here. Keep forgetting. Who can try? Wants to give it a shot? Daniel, what do you think?
Okay. So call me. Maybe we'll have to take in a parameter. No, first of all, in the function definition, let's take in a parameter number. Then there, yeah, okay, yeah, yes. Then we change that. Num, yeah. Then when we call operation inside the for loop, we pass in I.
Yes. So that is how you would pass like a value down to your callback. So they very good. So you know your way around functions. So, but let's try to also do the other way, which is using recursion. Who has come across recursion before? I think we did it a while back. I don't remember when. Bonus points if you can use recursion. Like if you've come across recursion in any other language, it's the same thing basically. Whatever methodology you use in other languages, come Python or C or C++, recursion is the same. It has the same blueprint. Anyone want to help us use recursion to solve that? Who has come across a recursion? Or what is recursion? Who has an idea of what recursion is?
I think I can try.
Okay.
So first, put a condition. If num is equals to 0, we return. Just return the function. So otherwise, call operation, then call repeats and pass in operation, and num minus 1.
Just like that, num minus 1.
Yes. Like that.
You sure?
I think so.
If it's wrong, it's going to cause like an infinite loop. But I'll just
I'm sure.
Okay, so can you explain what you're doing before we run it?
So the condition checks if, okay, the way I think about recursion, I think about it kutoka nyuma, from behind. So the condition is checking if num is 0. So if num is 0, it will return. Just keep that in mind. Then you call the operation. Then when you call repeat again, it calls operation with num minus 1. So if num was 5, on the next call, it will be num will be 4. Then the whole process will repeat again. Then num will be 3. The whole process will repeat again. Num will be 2 until num is 0. Now when num is 0, all the functions start returning, starting from the last one. They start returning until the last one is returned. Yeah, sort of something like that.
And do you know what we call this here? This first thing we are doing here?
I forgot the name.
It's called a base case.
Yeah, base case.
The base case. So like when your number is no longer, like you can no longer do any more repeating any more recursion, this is the base case. When number is equal to 1, then stop. Otherwise, if you don't have a base case, we'll have an infinite loop. It will loop forever because there's nothing stopping it from looping forever. So let's see whether it works. So node 02.js. Did we do?
It's because of the console log.
Which one?
The console log inside call me maybe.
Oh yeah, the num.
Yeah.
So you're very confident about your answer. You are immediately sure it is not because of an infinite loop. Yeah, so it works. So what it's doing is anytime num is not equal to 0, then it keeps calling repeat, but the second argument is now less by 1. So but don't you think we should say less than or equal to 0? Because if you give it -1, will it not try to?
Yeah, that makes sense. Yeah.
Because now this also takes care of -1, -2. Because if you don't give it, if you just tell it exactly 0, if you give it -1, it's going to try to do. It will not be executed in this code block.
Yeah.
Okay, so I have a question. So what is the difference between this and this? And will both of them work in this case if I say num++? Who knows what the difference is between these two? Because for me, they confused me for a very long time. Can we try and see what happens? We are having an infinite loop. I had to stop it because you see, those few milliseconds, it has logged all this. This is definitely not 5 times, 6 times. This is too much. So it's not doing the wait, I was supposed to do minus.
Minus, yeah.
Let's see. Still infinite loop. Okay. Does anyone have an idea why this is not working? Because I came across this somewhere.
I think I've ever seen an explanation somewhere. I don't know if it will make sense. But it will also explain why num minus minus isn't working. So when you use num minus minus, okay, this is very confusing. Okay, let me think about it for a second, Kwanzaa.
Anyone who wants to help him out?
Ian, I have a question. On line number 8, this repeat, it's like a JavaScript keyword. I've never seen it before.
No. Repeat is the same function. It's this function. So recursion simply means
you're calling repeat inside itself.
Yes, you're calling, yani inajiita, hence the name recursion. Keep calling yourself. I know, it's a very trippy idea. But the difference is we are changing the value of num upper. So if we start with a 6, on the first iteration, it's going to be 6, yes, but then we are going to decrement that value when we are using the other syntax. When we had num minus 1. So every time we call repeat again, it has a new value of num, less than before, -1. So it starts off with 6, then 5, then 4, 3, 2, 1.
Okay. And what if we don't have line number 7? We just call operation directly on line number 8. A network.
We call operation directly on line number 8.
Yeah, we don't just comment out or eliminate line number 7.
Okay. And then we invoke it here.
Yeah.
Okay. Okay, let's give it what we had initially, the right answer. Let's see. Num minus 1. Operation is not a function. Why is that?
It is getting the return value of that operation instead of the operation function itself, because you've called it.
Yes. You have invoked it at this point. So it's getting the undefined, because you have invoked it. So whatever is here is actually undefined. This is now undefined now, because you are calling that function. You are invoking it. So it's no longer like, this is now the value of the function, not the actual function. This is just the value of the function. So this will not work. That's why we need to call it outside, because we know what we are passing down to down here. This call me maybe, this one. It is a function that we can call here. And then operation, now we just pass in that function. But this one, this, Albert, do you know why this is not working? You have an idea why this isn't working?
Honestly, no. I went through that thing some time back, lakini nimesahau.
Yeah, hata mimi it's given me like headaches for weeks.
The recursion is not terminating because the value of num is never reaching 0. So if you do num minus 1, that would work.
Yes, which we had initially. Num minus 1 was working. Num minus 1. This works because we are changing the value of num. So this works. So the weird thing is, this does not work. This will not work. So you'll have an infinite loop. But this works. If we try it, it's working. So minus minus then num works, but num minus minus does not work.
Minus minus num is equivalent to num minus 1?
Yes. So there's a post incrementer and a pre-incrementer. So when you have minus minus, that's a pre-incrementer. You're minusing and then returning the value. But for the
decrement, I think. Decrement because it's a minus.
Yes, but you see that the difference is when you have minus minus before num, it's acting differently than when you have minus minus after. That's because
I'm saying it's a pre, not a post. It's a decrement, not an increment. I had said increment.
Yeah. It's decrementing. So what it means is when you have minus minus, it's first of all changing the value of num and then returning that value. But when you have minus minus afterwards, this minus minus is happening after. So at this point, your number is still just 6. It has not changed. Essentially, what it is doing is, if you had it this way, you would say num minus minus. This would be equal to, on this line number 8, num would still be 6. But now when you go to the next line and you try to console log now num would be 5. But if you use minus minus, it decrements first and then returns the value. If you do this, it's now already 5. So it's decrementing and then returning the value. But this one is returning the value and then decrementing. That's why you never get another different value here. because it never changes. It's always the same thing. Someone had asked this question a while back. I think it was Laura. And then I think I did some research, and then I found that they're different in how they operate. Any question? Anyone with a query? So if you want to continue the challenges, just download the package. We didn't even test our other solution, this one. So let's test it. This is solution number 2. So let's run that command. Then we now need to, what are we doing? We need to do something here. We need to remove this. Also need to remove this because we were just testing it out to see whether it's working. Okay. Then we need to change this also. And then let's verify the solution. Let's say 02.js. See whether we got it right. Yes, passed. So you can see they're actually doing the same thing we just tried to do just now when we were passing in something. Call function 1 times, 2 times. Yeah, so you guys can go through the rest of the challenges. They're very nice. Functional JavaScript, and they get more and more difficult. You can see we have one for map. This one is a bit more interesting. I think this one Albert did yesterday, where you loop over an array and then return them doubled. That's essentially what it's doing. But they're telling you not to use a for loop. So you guys can have a look at it and see whether you can be able to finish all the challenges. Okay, so now we have covered a lot of topics in the last, I don't know how many months. And this week was the last week where we had like a topic where we were discussing a particular thing. So now from next week, it should be working on the remaining projects. So the front-end mentor projects. Because we have spent so much time working on JS only, I believe that some of us might have forgotten how to read CSS. So for the next week, we will go through those front-end mentor challenges. Ideally, all of us should be able to finish them, but tutasaidiana. So from next week, that's what we're going to be doing. Then once we are done, we should take a break maybe for 1 week. Then when we resume, it is React, your favorite framework, React. So anyone with a question or a comment? Or maybe you don't want React, maybe you want Angular. In that case, I don't know where you're going to find a Angular developer.
Why there's no Angular developer?
I don't know of any. I don't know of any. I think I know one. A very few. Maybe it's my circles. I don't know. So any question, comment? Okay, all right. If you guys are okay and there's nothing else, from Monday we will start tackling projects. Going back to CSS and Flexbox and Grid and some JS. And then we also host those projects on GitHub so that by the time we're finishing, all of us can have something to show for it. All right, so I guess I'll see you guys on Monday. Make sure you enjoy your weekend. take some time to rest, hydrate, and I will see you guys on Monday where we'll start on the projects. And I hope you're enjoying the sessions as well. Meet Jane, who just joined us a few days ago, and Samoina. I hope the lessons are not too fast-paced.
No, it's actually okay for me. I think it's just internet rules that are making me lag behind a bit. Because when you guys are doing challenge number 2, I was still trying to set up that particular workshop from Node. So yeah, but I'm following. I think I'll just, learn the ropes vile tu time inaenda.
Okay. Okay.
The sessions are okay and they're so productive. I'm glad.
Okay. All right. So I'll let you guys go. It's already 7. I'll see you guys on Monday, and enjoy your weekend. Bye.
Bye.
Thanks, Ian.
You're welcome.